In this video, we will try to solve some problems using the properties of similarity of two triangles. So first problem is show that the triangle PST is similar to triangle PQR. So in question 1, the triangle PST is this and the triangle PQR is this. So what are we supposed to prove? We're supposed to prove that these two triangles are similar. So from the given information, we can say that if we are able to prove that these two sides are proportionate to each other, because P is already common to both of them. So we can say angle P is common. We have to now prove that PS by PQ is equal to PT by PR. Okay. First, let's find what is PS. PS by PQ will be equal to PS is 2 over PQ is 3. And our PT by PR is equal to 4 over 4 plus 2 is 6. That's our PR. So that's equal to 2 by 3. So we can now say that our PS is equal to PQ. Sorry, PS by PQ is equal to PT by PR. They are both equal to 2 by 3. Therefore, triangle PST is similar to triangle PQR in the first triangle. Then in the second one, we have to prove the same. So applying the same method, let's find PS by PQ. That's equal to PS is 2 over PQ is 2 plus 3, that's 5. And let's find what is PT by PR. Our PT is 2 and our PR is 5. So we can say that PS by PQ is equal to PT by PR. And since angle P is common in both the triangles, we can say that the triangle PST is similar to the triangle PQR. I don't have space here, but you will have to write that down as your final conclusion. In this question, we are asked whether is triangle ABC similar to triangle PQR. We can see that they have the common angle here at B and Q. So let's see if the sides are proportionate. So let's do first PQ by AB. PQ by AB is equal to 3 by 6. That's 1 by 2. Now what's the other side which is adjacent to this angle? It's 4, or rather QR over BC. So QR over BC is equal to 4 by 10, and that's equal to 2 by 5. So our PQ by AB is not equal to QR by BC. Therefore, triangle ABC is not similar to triangle PQR. Okay, in this problem, the question says, observe figure 4.18, which is this figure here, and find the angle P. So you're asked to find the angle P, which is this angle here. Okay. Now, if these two triangles are similar, we can find this angle easily because we know this angle here is 180 minus 60 minus 90. So that will be 30 degrees here. So we know the angles of this triangle. So if we can prove these two triangles to be similar, then we can move, or we can bring those angles into this triangle and we can find this angle. So let's see if they are similar. So let's take, now we see that these two are 90 degrees, so they're equal. So let's take the adjacent side to them. So let's take the longer one, okay, 3 AC. So let's find AC over PR, and that's equal to 3 root 3 over 6 root 3. So that is 1 by 2. Then let's find AB over RQ. That's equal to 3 over 6, and that's 1 by 2. So we can now say that the two triangles are triangle ABC is similar to triangle PQR. Therefore, the angles are similar. Therefore, angle P is equal to 30 degrees because that's the corresponding angle to this. Okay. In this example, the question is, a boy of height 90 centimeters is walking away from the base of a lamppost at a speed of 1.2 meters per second. If the lamppost is 3.6 meters above the ground, find the length of his shadow cast after 4 seconds. So the boy is walking from the base, okay, from the lamppost, in this direction. Now his speed is 1.2 meters per second. Okay, that's the speed at which he is traveling. And we need to know what was the shadow that was formed. Let's assume that he has walked this distance. The time they've given is 4 seconds. In 4 seconds, he has crossed this distance. So this will be 1.2 into 4, 4.8 meters. Okay, so he's walked 4.8 meters. And the shadow would be in this angle, right? The lamppost is here, so the shadow will fall in this direction. Okay, so this should be his shadow, which is X. All right. So considering that this is the shadow that is formed, X is the shadow, we can see now we have two triangles here. One triangle which is EBA, and the second triangle which is EDC. All right. So if we find this length here, we know what's the shadow that was formed after 4 seconds of walking, which is 4.8 meters from the base of the lamppost. Okay. Now, so the given speed was what? The speed given is 1.2 meters per second. And the time taken is 4 seconds. And the distance he has traveled is 1.2 into 4 that is 4.8 meters. Okay, now what we're going to do is we're going to take these two triangles. They're similar triangles. You can see that they're similar triangles because this is parallel to this. So we have seen earlier that if this line is parallel to this line and it's inside, then these two triangles are similar. So just for your understanding, let me draw an imaginary line here. So you have two triangles, right, which are similar. If they're similar triangles, then the ratio of their sides, so let me say 4.8 plus x is my BE full length, because this BD is 4.8 plus the x is 4.8 plus x over x, which is the base of this triangle here, should be equal to 3.6 over 0.9, which are the corresponding sides of the similar triangle. 3.6 divided by 0.9 will be 4. So 4.8 plus x is equal to 4x. So our 3x will be equal to 4.8. So x is equal to 4.8 divided by 3, and that is 1.6 meters. So that's our answer. So 1.6 meters is the length of his shadow. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.